Welcome to everyone that's joining today. We appreciate your attendance and hope you will find it useful. Now, as we go through the presentation, if you got questions, please do not hesitate to ask those and we will do our best to respond to them. So let's get going. As you can see, there is this slightly conventional title when GIS is just not enough, because what we would like to present you is Bentley's unique approach to linear referencing and what we call logical first, as opposed to GIS or spatial first, but also how you can, within one system, manage the whole life cycle of your assets from design to retirement, making AssetWise ALIM a truly comprehensive network and asset management platform. So let's start with the basics. You have a road network you need to manage in real life. So you need to model this network, and the way we model networks in our system is starting with the smallest unit. You can call it a segment or a datum. And you probably now expect me to show you something like this, right? A segment. Well, not really. A segment datum in our system is something more conceptual or logical, if you like. Something that as a minimum, it has an ID, a length, a start node and an end node. And it can also have a geometry. But this is just another attribute of our segment, not what defines it. Because at the end of the day, at least within the highways roadways industry, you don't care much about the geometric representation of your streets. You don't care if your street looks like this, or like this, or like this, or even like this. Okay, maybe you need to start caring about this particular street. But the point is, what you really care about is the measured lengths of your segments. That won't change depending on how you digitize the line work, on which scale, or using what projection. Okay, and you also care about the logical connectivity of your streets. And because you know that segment 1, 2, 3, 4 is connected to 3, 4, 5 by node 0001, you can create a route, or what is called, or we also call a linear group. So in this example, I've got route R1, which is comprised, its members are datum 1, 2, 3, 4 and 2, 3, 4, 5. And because this datum have geometries, my route also has a geometry, which is the aggregate geometry of the member datums, which again is just a derived, calculated this time, attribute of the route, much like the route's length is the sum of its member lengths. And this first logical as opposed to first spatial model provides a lot of flexibility. And here are some examples. It's flexible because it allows you to manage your network the way you need to. An example may be divided highways. So consider this scenario. This is how your network is digitized in the real world. So this is your right roadway, and this is your second one, and they share a vertex. And on the left side, this is your first one and the second one, but despite what the actual real world geometries may be, because of reporting requirements and the way you may want to model your routes, you may not want to logically have different nodes. So the datums may geographically share a vertex, but not necessarily a node. And so logically, the connectivity would look like this. Okay? And another example where the flexibility of logical first approach becomes apparent is in distance breaks in routes. In the example here, say that you're only interested in the red route, survey route 1. This route is discontinuous. Okay? The yellow route here is not part of your survey. So this would be difficult to handle in a spatial first environment. In our case, what we do is that we add a distance break to provide the connectivity. And we do this conceptually, logically, so we can see that the members for this route now include the distance break. Okay, but which also has a length, but obviously does not have a geometry. The geometry is null. And similar to the previous example, the other datums do have geometries. And so our route also has a geometry, which now is a multi-part geometry, and again is treated simply as a derived attribute similar to the length of the route. Another case where a special GIS first approach would not be ideal is shown here. So consider this route where we have the actual physical milepost reading at reading 35, and we have 3 datums that make up the route. Okay, datum 1, datum 2, and datum 3. But because a new housing estate is built element 2 has to be realigned. So depending on how you want, and it's now shorter than the original length. So depending on how you want to manage your network, you could just recalculate the route measure for the whole route. However, if you do that, all the mileposts after the realigned element will now show incorrect mileage. And you might not want to have to replace all the mileposts. And that's fine in our system, because it will automatically detect that. So in this example, these are the route offsets before the realignment. Okay? You can say that member 1 got a length, the member length of 10, number 2 20, and number 3 again a 10. And this is how the members would look like after the realignment. Route offsets won't change automatically unless you rescale your route, but the system has now detected that the discrepancy and create a point of equation, or POE. So a POE, point of equation, is a discontinuity in the measured distance of a route at a known point on the on the ground. And in this case, it tells me that there is a gap of 10 units, 10 meters, 10 miles, whatever you set up your network units to be. And it can do that because, again, it deals with the route measures logically and not spatially. But that's not all. The system supports multiple network types that you can define depending on your business needs, like roads, cycle tracks, footpaths, water and wastewater networks. And for each network type, you can define the units of measure that you want, and you can define the naming convention attribution, and you can also define hierarchies within each of the network types. So they can be datum segments, they can be routes, or they can be non-linear groups, or even groups of groups. So, for example, lots of datums make up. A datum group is made out of datums. Then you can have group of groups that is made up of other member groups, and so on. And you can have any level and any depth in the hierarchy that you want. And we also have a flexible model when it comes to events or that occur on your network. Say, the asset, inventory on your network, asset data, or safety or traffic data. And as with the network types, they can all be completely user-definable when it comes to attribution and rule-based. We can define rule-based location management, which means that you can define how your routes and event locations will react to any changes to the underlying datum elements or to the LRS itself. So if, for example, you reshape one of the datum elements, that will shape the route, and that will reshape, obviously, will get a new position, a new location for the assets or any event that's located along that datum. And of course, datums, groups, events, assets all have geometries. In actual fact, group geometries, as already mentioned, are dynamically derived based on the underlying datum, and event geometries based on dynamic segmentation. So our network objects do have geometries, but in theory we could have the full system working without any maps. Do we want to do that? Obviously not. This is where the GIS bit comes in. Of course it's required, and of course we use it. We use it for map-based editing. We obviously use it for network visualization. We use it for spatial queries, and in general, we use it for all the the GIS goodness that you can get from a GIS. And in actual fact, we offer a comprehensive web map-based editing tool where you can edit all your network and event or asset data. That tool, called Asset-Wise Linear Referencing Services, or AWRS for short, is built around open source components on the UI, like map servers, our map rendering engine, and open layers for the UI and map interactions. But this can be the topic of another tech talk. Okay, so now I think we can open the floor to questions. Feel free to ask them now, or you can always contact Russell, Paul, or myself at the email addresses now showing on your screen. Thank you.